Okay guys, this is a full walkthrough of page 18. So we've got this formula, z equals x minus mu, which is the mean, over sigma, which is the standard deviation. The idea of this formula is it can take us from a random variable x and standardize it to the standard normal distribution z. Okay, so let's have a go. All we are going to need to be able to do this is a mean and a standard deviation and an x value that we want to transform into a z value. Okay, so the weights of bars of soap have a mean of 102 grams with a standard deviation of 1.5 grams. So what I like to do for these is I like to draw a picture of what I'm looking at, and I just find it quite satisfying drawing the normal distribution. Now, what is our mean value? Our mean value is 102 grams. Mu equals 102. This is our x. And the standard deviation is 1.5. And they are asking us to find what 105 grams is. So on this, so see how 102 is here? 105 is going to be to the right. And it's probably somewhere around about here. So they want us to find, so this is our little x, and they want to find out what the corresponding little z would be. So I'm just going to draw it on the first one, and I probably won't draw it on the later ones. So it's when we're transforming it into this z random variable, which, as you may remember, has a mean of 0, mu equals 0, and standard deviation equals 1. So what we're doing is we're trying to find this x value where it would be on z. So it's going to be in a proportional place. It's going to be here. But what is the value? So let's work it out. So 105 grams. So all we do is little z is going to be equal to little x minus mu over sigma. Now, to be honest, I get a little bit confused as to how the book swaps in and out big x's, big z's, little x's, little z's. All you need to remember is that x is the random variable you're looking at. In this case, it's a bar of soap or bars of soaps. They have different weights. And z is just when you're standardizing that. So when we input our little x, 105, which is here, in our random variable x, we just want to know what the z equivalent is. So big X is the random variable, little x is the value it takes, big Z is the standard normal distribution, and we just want to know little z, the value that is equivalent to that little x. So yeah, we'll get our heads around it eventually. So let's do it. So little x is this 105 grams, so that is what little x is. So we're just going to go 105, we're going to minus off the mean, which is 102, and then we're going to divide it by the standard deviation, which is 1.5. So that's what little z is going to be. So let's do that. Oopsies, equals 105 minus 102 is 3 over 1.5. That is 2. But you can just do that on your calculator. I would suggest doing it like this on your calculator. Maybe keep the top bit in brackets, 105 minus 102, and then you can either do divide or over. Let's just do over, so it's the same as what's being written, over 1.5, and that comes out with 2. Another way you can do this is you could just go 105 minus 102, click equals, and then divide it by the standard deviation of 1.5. So this shows us what the equivalent z value would be. So this little z would be equivalent to 2, and that is proportional. It seems weird that we're doing this, and we haven't really explained why we're doing it, but it's one of the first steps in solving these problems using tables, and it's also really useful for merit and excellence skills later on. So yeah, this is a skill that you kind of need to have an understanding of. Okay, let's do 100 grams. So we'll skip writing out the formula this time. I'm just going to write the x value is 100 minus the z, or minus the mean, which is 102, over, I might put a little z here, over the standard deviation 1.5. So this time 100 minus 102, actually let's just go straight into the calculator. 100 minus 102 gets us a negative value, negative 2, and then we're dividing that by 1.5. So it's negative 1.3 recurring, equals negative 1.333. Just going to round that off at 3 dp. That's the z value. So pretty much what we worked out is this x value of 100, which would be somewhere around about maybe here, is equivalent on the z table to a value just here, which is z equals negative 1.3 recurring. So we're just really using the formula. I'm just trying to explain it as we go. Okay, the length of licorice straps have a mean of 355 millimeter with a standard deviation of 2 millimeter. Calculate the z values for straps with the following lengths. Okay, so we're going to get a little bit lazier again. So all we do is z equals the x value, which is 355 here, minus the mean, which is here, 355, and then we're dividing it by the standard deviation, which is here. So these are the values we're using. I'll just label them. Standard deviation is that one, mean is that one, and this is our little x. So standard deviation was 2. So 355 minus 355 gets us to 0. 0 divided by 2 actually gets us to 0. Well, that makes sense because it just means that this x value, because it's the same as the mean, the equivalent z value is going to be right in the middle of the z standard distribution, which is 0. So that makes sense. Okay, let's do the next one, 360. So we're going to go z equals 360 minus 355 over 2. That means it's 5 over 2, so it's 2.5. That is the z value. Okay, the next one, 349. Z equals 349 minus 355 over the standard deviation, which is 2. That's going to get us negative 6 over 2, which is going to get us negative 3. Okay, the areas of sections in a subdivision have a mean of 560 meters squared with a standard deviation of 22 meters squared. Okay, so we've got our mean value. I'll put a little mu here. We've got our standard deviation. I'll put our sigma there, and this is our x value. So let's just do it. Little z is going to be 605 minus 560 all over 22. That's going to get us negative, oh no, 45. 45 over 22. Oh, it would have. It's nearly such a beautiful number. If that was 22.5 or if that was 44, it would be a beautiful number. But I know it's not a beautiful number. It is 20. Oopsies, wrong. That is 2.045. Now, the thing to also bear in mind is if these values are anything outside of the range of negative 3 to 3, you've made a mistake. The most values will be somewhere between sort of negative 3.1 and positive 3.1. If they are any larger than that or smaller than that, you've probably made a mistake. Okay, let's try 470. Z equals 470 minus the mean of 560 all over the standard deviation of 22. 470 minus 560, that's 110. 110 over 22. Ooh, that is a nice number, isn't that 5? I'm pretty sure. Wait. Didn't we say that if the number's outside of that range, you probably made a mistake? Ooh, I also, this is going to be a negative 110, right? 470 minus 560. Well, I know that 560 minus, oh, no, that should be 90. My bad. That's why you should probably not do these in your head, guys. 470 minus 560. Negative 90. Whoops, that's a blunder. Negative 90. So I know that this is going to be wrong, but we'll deal with that. And then divide it by 22. So it's actually negative 4.091. To be honest, this is outside that range I was just saying. So this area is not actually going to be, it's not a realistic area, because, yeah, it doesn't matter. You guys don't need to worry about that too much for now, to be honest. Okay, let's keep moving. A few more questions to do on this page. Okay, the average lung capacity of teenagers is 4.8 litres with a standard deviation of 0.35. Calculate Z values for blah 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 blah. Z equals, first we put in our X value, 4.7. We then minus off our mean, divide by our standard deviation. Sometimes when it's too hard to do in your head, you just do it on the calculator. 4.7 minus 4.8 equals, then divide it by 0.35. Our Z value comes out at negative 0.286. Next one, 5.7, I should probably put a Z there, minus 4.8 over 3.5. Let's do that one now. 5.7 minus 4.8 divided by 3.5. Oopsies, that will not work. Do not do that at home. 3.5. This one gets us 0.257. Okay, we're nearly done. I'm going to see if I can move my camera without ruining the focus completely. Okay, the track length on a CD have a mean, this is out of date, have a mean of 3 minutes and 18 seconds with a standard deviation of 11 seconds. Calculate Z values for tracks of the following lengths. Convert these times to seconds first. I mean, they made this way too easy by telling you that hint. That hint's like the only thing that makes this good problem solving. Okay, mu was 3 and 18, so all I'm going to do is I'm just going to go 3 times there's 60 seconds, and then plus 18. So that's 198 seconds. And the standard deviation's already good. And then let's just translate these while we're at it. So 2 times 60 plus 23. And also 3 times 60 plus 52. So this one's going to be, oopsies, this one's going to be 143. And this one's going to be 232. So now let's work it out. Little z equals x, little x, minus the mean over the standard deviation. Then I'm just going to do this one as well, so we do all the calculator work at once. 232 minus 198 should stay the same, over standard deviation of 11. Okay, so now let's compute that. 143 minus 198 equals divided by 11. So that's negative 5. Again, that value should not be appearing here. Badly written question. 232 minus 198 divided by 11. 3.091. So that's a full walkthrough of page 18 in the Walkermaths book. This is how you work out Z values. This is not really building up an understanding of what Z values actually are yet, but we will build onto that as we go through it. So yeah, hope you guys managed to get those.